All right, let's work another example of a rational equation. And we're going to begin it just like we began the first example, and that is by excluding some solutions. All right, and so let's look at our denominators. We have a matching denominator of x minus 2. So I'm going to take x minus 2, set it equal to 0, and solve for x. I add 2 to both sides, and I get x equals 2. Now, that's actually what we're going to exclude from our answers. Why? Because notice here, if I plug in 2 for x, I get 2 minus 2, which is 0. And remember, that's the one number we can never, ever, ever divide by in math. So I begin by saying x cannot equal 2. Our second step before solving the rational equation is trying to figure out what that least common multiple is. Notice that I have x minus 2 as a denominator, and I have 3 as a denominator. All right, so how does this least common multiple work? Well, keep in mind, it's called a least common what? Multiple. All right, and so I'm not going to add the 3 to this term. I'm not going to subtract it. It's a multiple, and I know that I sound like maybe the teacher from Ferris Bueller here, but you've got to keep in mind the English will guide your math. And so by the nature of the word multiple and the definition of multiple, I am going to get my least common multiple as 3 times x minus 2. All right, and so if I multiply every single fraction by 3 times x minus 2, then I will be able to eliminate those fractions. So now I'm going to multiply every single term by 3 times x minus 2 over 1. Now keep in mind, I'm getting your life's on repeat here. Why am I putting it over 1? And that is so you remember to multiply the fractions straight across. And that's exactly what I'm going to do here. I'm going to multiply 3 times x minus 2 times x all over x minus 2 equals 3 times x minus 2 times 2 all over x minus 2 minus 3 times x minus 2 times 2 all over 3. Now, again, what was our motivation in doing this? To get rid of the fractions. Do we get rid of fractions? Absolutely. Notice in the first term, the x minus 2's cancel. In the second term, the x minus 2's cancel. And in the third term, the 3's cancel. And so what does that leave us? That leaves us 3x equals 3 times 2, which is 6, minus 2 times x minus 2. And I'm going to now distribute that minus 2 at the on the right-hand side to get 3x equals 6 minus 2x plus 4. Now, why is it plus 4? Because it's minus 2 times minus 2, which is going to make it a plus 4. And now I can actually solve the linear equation that I'm left with. All right, and so I begin on the right-hand side combining my like terms. So I have 3x equals, and I'm just going to keep my minus 2x, and I'm actually going to do the operation 6 plus 4. Note, I do not change the sign of the 6 or the 4 because they are on the same side of the equal sign. So I can do exactly what I read, which is 6 plus 4, which gives us plus 10. Now I do want to move the minus 2x to the left side to get my x's together. Now, because I move it over the equal sign, I use opposite operation, which is going to give me 5x equals 10. My final step here is to move the 5. Since it's 5 times x, I'm going to divide both sides by 5, giving me x equals 2. Now do I go whoop whoop? Problem's done? No, because what was the one number that we could not have as a solution? And I'll go back to our original page. We have this at the beginning, that x cannot equal 2, but wait a minute, I got x equals 2. So what does this mean for us? Our answer is the empty set or no solution.